Okay, in this video we're going to look at linear equations in one variable. So this would be things in the form ax plus b equals c, where we have x and a bunch of numbers. So for example, like 2x plus 3 equals 7, or maybe even like 1/4 x minus 8 equals 10, things like that. Okay, so there's an x and some numbers. All right, so starting with some properties for linear equations, we've got the addition property and we've got the multiplication property. So they say, both of them say pretty much whatever you do to one side, you have to do to the other. All right, so if you think of this, you can think of an equation as being balanced, meaning the two sides are equal, which is like being equal in weight. So let's say that we've got, let's use our 2x plus 3 example. So I've got a block that's 2x, I've got a block that's 3. Okay, and then I've got a block over here that's 7. All right, so what the addition property says is that I can add the same thing to both sides. So I can take, like, let's say I can take a 2 block. If I add 2 to this side, then to keep it balanced, I'm going to add a 2 to this side. Okay, as long as we add equal amounts of weight on either side, then we can do that. I could put the 2 and the 3 block together. I could put the 2 and the 7 block together, or, whatever. Doesn't have to be that. Okay, so that's the idea for the addition property, is that I can add or subtract the same amount from both sides. The multiplication property says that I can multiply both sides. So I could double both sides, triple both sides, halve both sides. But on this one, I can't put that C, I can't group the C anywhere I want. I've got to multiply the entire left-hand side and the entire right-hand side. So like, let me switch colors here. All right, so let's say that I want to double what I have here. Okay, I can't just double the 2x and just double the 2. Okay, that's not going to keep things balanced because I haven't added the same amount to each side. I would have to double all of the blocks like this. Okay, and then what's our other one? 3. Okay, so if I'm going to double, I've got to double everything. So I've got to double the entire left-hand side and the entire right-hand side. I can't just throw it in wherever I want it. Okay, so that's the main difference between the two of those. Okay, so now let's look at an example. Let's use our 2x plus 3 example because we've got that. So 2x plus 3 equals 7. Solving this using the addition and multiplication property. Once you get a linear equation into this form, you can use these two properties to solve it. So we can see that the x term, the thing with x's, we've only got one of them. Okay, so we've simplified it down to where we just have one x term. And we want to try to get the x by itself. So that's what solve means, is to have x equals a bunch of stuff that isn't x. So we need to get the x by itself. Okay, so we need to do the opposite. Now, I can use either property. They're always legal. So if you say 2 times x and you want to divide by 2, you can do that. But you have to divide everything by 2, or you have to divide the whole side by 2. That's going to end up a mess. So even though it's legal, we're not going to do that. Let's get this group by itself. Let's get this term by itself first, and let's get rid of the 3. So to get rid of that, we're going to do the opposite. It's plus 3, so we're going to do minus 3. Okay, so we're going to have 2x equals 4. All right, now again, we want to get x by itself. We want to do the opposite. This is 2 times x, so the opposite would be divide. Divide by 2. 2 over 2 is the same as 1, and 1x is just x. And 4 over 2 is 2. So our solution is x equals 2. Remember that you can always check these by putting it back in the original equation. So my original equation is 2x plus 3 equals 7. I'm going to plug in x equals 2. And that way I can check it. I get 4 plus 3 equals 7. Indeed, 7 is equal to 7. So that does check. That is the correct answer. If I got something else like 6 equals 7, then I know that answer was wrong and I have to go back and fix it. Okay, so that's the basic idea for linear equations. Let's talk about a couple of other types of linear equations. Let's look at one that has fractions. Okay, now we could deal with fractions, or the easier thing is just to get rid of all of them at once. So what you can do is you can clear them with the LCD. Okay, by clearing them, I mean multiply by the LCD to get rid of all the fractions. All right, now you can use any common denominator. The LCD is just the best one because it's the smallest one. So let's look at an example. Let's say we have x plus 2 over 5 minus 1/2 equals 3/4. Okay, so we want to find the LCD or any common denominator, but the LCD would be best. Okay, so the best common denominator, the least common denominator, would be what all these numbers go into. That's smallest. So 5 and 2 both go into 10. 10 and 4 both go into 20. Or you could do 5 and 4 goes into 20, 2 goes into that as well. So compare them until you figure out what number they all go into. So 20 is the LCD. Now, if you're not sure what the LCD is, you can just multiply all the denominators together, and that will work as well. So you could do 5 times 2 times 4 is 40, and you could multiply through by 40, and you would get your numbers would look different, but you'd get the same answer in the end. Okay, so let's try it. Let's multiply through by 20. We're going to multiply the whole left-hand side by 20 and the whole right-hand side by 20. All right, now when we do that, we need to distribute. So we're going to distribute on the left. That should look like distributing. Okay, so we're going to have 20 times x plus 2 over 5 minus 20 times 1/2 equals 20 times 3/4. Okay, now this number should cancel with all the denominators because that's why we picked it. Okay, so let's see what happens. 5 goes into 20. Let me do this in another color. 5 goes into 20 4 times. Okay, so I'm going to reduce that. 2 goes into 20, and I'm left with 10. 4 goes into 20, and I'm left with 5. Okay, if you don't clear all the fractions, that means you picked the wrong number and you've got to go back and pick a new one. All right, so now what are we left with? We've got 4 times x plus 2. Now remember, a fraction is a type of grouping, so secretly there's a pair of parentheses there that we just usually don't need, but we want to make sure we do 4 times the whole thing, so we need those parentheses there. That's very important. Okay, we need those parentheses. Minus 10 times 1 equals 5 times 3, 15. Oh, let me write that out because I did the other one. Okay, 5 times 3. All right, so here's what we're at so far. So now we need to clean this up because we want it to look something like this. Okay, so let's go ahead and distribute that 4. We've got 4x plus 8 minus 10 times 1 is 10 equals 5 times 3 is 15. Okay, we're trying to get x by itself, so let's keep cleaning this up. We've got 4x, we've got plus 8 minus 10, that's going to give us a negative 2. Okay, so now we look like the original problem. Now we want to work on getting x by itself. So we want to do the opposite. We're going to add 2 here and add 2 here. Negative 2 and positive 2 is 0. And we've got 4x equals 17. Let me come up over here so we got a little bit of space. 4x equals 17. And then we want to finish getting x by itself. It's 4 times x, so we're going to divide by 4. X equals 17 over 4. Okay, and you can go back and check that. That one might be a little bit difficult. You might need a calculator for that one. Sorry, that's my dinner. Okay, so that's the idea with fractions. You're going to clear them out by multiplying by the LCD. Okay, that gets rid of all the fractions, makes life a whole lot easier. Decimals, same idea. We're going to clear it out by multiplying by powers of 10s. Okay, powers of 10. So let me put up here in our little notes. Remember, if you multiply by 10, that's going to move the decimal place 1 time. Okay, if we multiply by 100, that's going to move the decimal place 2 times. Like that. Okay, so if we have 0.03 and we multiply by 100, that's going to move it 2 times, and we've got to fill in a 0, and we get 30. Okay, so we're going to multiply by 10, 100,000, whatever it takes to clear all of our decimals. Okay, so however many decimal places we have here, we need that many zeros on our multiple of 10. Okay, so let's try one. Let's say we've got 0.08x plus 0.2 equals 0.05. Okay, so we're already in this linear form. Okay, there's nothing really that we can combine or distribute or clean up. We're in good shape. So we need to work on getting x by itself. So the first thing we're going to do is do the opposite. We're going to, oh, no, we're not. You can do it that way, But again, we're trying to clear out the decimals, multiply by tens. Okay, so first step, we're going to clear out all of the decimals. Okay, 10 would move us 1 decimal place. That's not enough here. I need 100 to move us 2 decimal places. So I need to clear 2 decimal places here, 1 here, 2 here. So I need to multiply by something that'll clear all of them. So I'm going to multiply by 100. Okay, I'm going to multiply the whole equation by 100. Okay, and that means that we're going to distribute that 100. Okay, now we could write this all out, but we know that multiplying by 100 is going to move the decimal place 2 times. So rather than writing all this out, let's just move the decimal place 2 times. Okay, so it's going to move this one 2 times, it's going to move this one 2 times, and we fill in with a 0, and it's going to move this one 2 times as well. Okay, so when we multiply by 100, what do we have? We're going to have 8x, we're going to have 2, 0, we're going to have 20, and we're going to have 5. Okay, so I picked a power of 10 that would clear all of the decimals, and I have to multiply by the same amount to all of them. I can't just get rid of the decimals. I've got to multiply by the same amount throughout. Okay, so now we've got a linear equation in the form that we want. We can work on getting x by itself. So we're going to subtract 20. Okay, positive 5 and negative 20, we need the difference. The difference is 15, and it's going to come out negative because the bigger number is negative. And then we want to get x by itself, so we're going to do the opposite. 8 times x, the opposite is divide. 8 over 8 is 1, and 1x is x. And we're left with negative 15 over 8. Okay, now one thing to note, and I'm not sure how MyMathLab wants the answers. A lot of times if you start off with a question that's in decimals, you want to answer in decimals. You kind of keep the format the same throughout. So pay attention to whether or not the answer wants you to be in fractions or decimals. Usually if it wants you in decimal form, it'll say it around to 1 or 2 decimal places, something like that. So pay attention to the format of your answer as well, especially because MyMathLab's a little bit picky.